Hi, this is Mike Turner from the Epic team, and this is a short tutorial about running OpenFOAM on Epic. In this tutorial I'm going to run one of the OpenFOAM tutorials locally on my laptop. I'm then going to prepare the case and upload the job to Epic and submit to a remote HPC cluster. So to start off with running Foam locally, I'm using the Docker containers from OpenFOAM.com. So I've got the install and start script here. I've already run install, so I'm just going to start that, and that will start a Docker container with OpenFOAM installed. Okay, so I'm just going to use the motorbike example for this demo. So if I just copy that, take a copy of that. Okay, so I've got the motorbike case here. Okay, for the tutorials, you've got the all run script that runs the various components of the foam workflow needed for this case. So it will create the mesh, decompose it, and run the solver. So for my local run, I can just simply kick that off here, and that will start running. So we'll let that go on for a bit, and we'll come back to it when we get to the solver stage. Okay, so you can now see that Simple Foam is now running locally on my laptop. If I just background that, and we can just check the logs just to make sure everything's okay. Okay, so you can see it's happily running along, taking about 2 seconds a cycle at the moment here. Okay, but say this wasn't running fast enough, say my laptop's not that powerful, I want to speed this up, or I want to run a larger mesh, so I might need to scale up beyond the memory on my laptop. What can I do? And this is kind of where Epic comes in. So the idea being that now I've got a working mesh here, I can upload it to Epic and scale the solve and get it done faster, or on a machine that I wouldn't normally have access to. So I'm just going to kill the solver here. Okay, and then I can tidy up this case ready for Epic. As I said earlier, Epic is really focused on the solver portion of the foam workflow. Since the all run script has already created the mesh, this case is good to go, and I've run the solver a few cycles to check everything's okay. So I'm just going to tidy up some of the folders we won't need. So we're not going to need the processor directories because we'll run reconstruct par again on Epic. I'll remove the logs, and I'll also remove the all run and all clean scripts because we don't need those. We won't need the post-processing directory because that will run again. Okay, I'm also going to move that origin file, that time step, just to time step 0, and then have a look at my decompose par. So in the tutorials, the decompose par dict has got a different name, so I'm just going to move that to standard name. And I'm also going to quickly check out the method. So I'm going to change the method to Scotch. So in the tutorial it's set up for 6 partitions. We might want to run more partitions on Epic, so I'm just going to give myself a bit of flexibility by switching to this Scotch partitioner. Okay, that's it. Now that case is prepared and good to go. So we're ready to run the solver via Epic. So the first thing to do is set up an Epic account. So if you launch a browser and go to epic.zenotech.com, then there's a simple sign up form. So if I'm just going to sign up as a demo account, it's first name, last name, and email. It's quite easy. Okay, and that's it. So you'll then shortly receive an email just with your sign-in details. So if you follow those sign-in details, and you'll then log into your desktop. Okay, so I received the sign-up email and I've now logged into Epic. The first view you see is your desktop view here, your dashboard, and this gives you a summary of your current activity in Epic. Obviously this is a new account, so nothing's happening here. For signing up, we add £10 of credit to your account, which is more than enough to get this motorbike case running. So feel free to use that to try Epic out. So the first thing I need to do is upload the data I've just created to Epic. So if I look on the left-hand side here under Data Manage, I can click that and it takes me to my Epic data store. This is your kind of staging area for all of your HPC related data. You're going to organize it how you like with folders. So I'm just going to create a folder here called Foam. And now I need to upload my motorbike case. I've got a few different options with uploading. I can upload in the browser using this upload file option here. or I can connect to my data store using any AWS S3 compatible tools. If I want to do that, click on that cloud icon and it will give you the instructions to do that. I'm just going to upload in the browser just because the motorbike case isn't that big. So I'm going to upload to the browser. I'm going to just grab my files. So it was this. That's the motorbike case we prepared earlier. So I'm just going to drag that into here and it will copy all of that up. Okay, it takes a few minutes just because it's uploading. Okay, so that's now finished uploading. I can hit done. And I can see my motorbike case is now in my Epic Data Store. With this Epic Data Store, I can do things like copy and delete folders and files. I can go in and have a look at the contents of any text files. So if I want to check my control dictionary, I can see I get a quick peek at the contents, which is quite handy sometimes. Okay, so now my data is in place. The next thing I need to do is actually submit a job. So to do that, I can use the New Job option on the left-hand side. So if I click New Job, and then give a list of applications within Epic that you have access to. There's a variety here, but we know this is a Foam 2006, so I'll select that particular version, and off it goes. And then I point Epic at the data. So obviously I've uploaded the motorbike case. For Foam, you just point at the root directory of your case, so the motorbike folder. Okay, and I can give my job a name, so I'm just going to call it motorbike, just the name of the folder is default. And I can put an invoice reference here if I want to track this particular spend against a project or a budget. I've got the default output options and notifications, so I can get emails when my job state changes, or I can get a tail of the log file sent to me periodically, which can be useful. And I can click on the next step. This is the Foam configuration. So Epic will check your Foam case, check that it's a valid case, and pull out some key control parameters. So it's detected it's simple foam, it's got start and stop time, and it's also detected it's a 1200 cell mesh. It's given me the option of run block mesh because it's detected a block mesh dict, but I'm not going to run that this time. I'm just going to go straight into decompose par and how many partitions I want to run as. So it's detected that it's initially configured for 6, but I can change that. So say this case needs more cores, so maybe I want to run it in parallel. So I'm going to go for 48 cores, and I'm going to run the solver from time step 0 until, again, I'm going to maybe beef this up a bit, go to 1000 seconds. Okay. Behind the scenes, Epic will rewrite your control dictionaries as it submits the job. And then I'm going to run reconstruct par and reconstruct all my time steps. Okay, so that's the very high level, simple Foam configuration. And the next step is to choose a cluster to run it on. So you can see my job is actually composed of 3 steps: decompose par, simple foam, and reconstruct par. The first, decompose par, is a serial task. Simple foam is a parallel task, 48 tasks, and I only put 1 task per core. So reconstruct par is serial as well. And I'm going to say a maximum of 1 hour for each of those tasks. So that gives me a maximum runtime for this job and a size for this job. Epic then takes that and presents the resources you could use. So it's a mixture of resources here, cloud resources and supercomputing resources. So you see these top ones here are C5, which is an Amazon Web Services type. CFMS is a Cray CS400. You've got Petafor, which is the machines at the University of Cambridge, and Scafell Pike, which is a large cluster at the STFC in the UK. So I'm going to sort by job price. You can see my cheapest option here is the C5 36-core spot price from AWS. My most expensive, again, is the 72-core AWS node. I'm going to go for one kind of in the middle, and maybe go for this CFMS machine here. So I can get some more information about the cluster. It's about 3,000 core cluster. It's 24 cores per node, so my 48 core job is going to take up 2 nodes. So I'm just going to select that. It'll give me a breakdown of the price, maximum price, based on my estimated runtimes. So it gives me the infrastructure cost. There's no application charge for Foam, and then a service charge, which is how Epic is paid for. And then if I hit submit, it will then go off and run that job for me. So I can see now in my active jobs page, I now have this one motorbike job pending submission to the cluster. I can click on job info and get some information about the job. So this will go through various stages. It will get submitted to the cluster. Epic will then stage the data from my data store to the remote cluster. It will then submit the job to the batch scheduler, run the job. I can monitor it through this interface. I can do things like look at the log files, look at the residuals. And then when the job finishes, Epic will stage the data back to the Epic data store for me to retrieve. So we'll just leave that running for a second. Okay, so you can now see the job is running. Decompose power is completed. I can click on view logs to check out the logs. Okay, so you see it did 48 processes, and now the solver is running. While the solver is running, I can also view the logs, and I can refresh it to get the latest tail. It's probably finished by the time. Okay, so it's run up to 1,000 cycles already. Okay, and you can see decompose, reconstruct power is finished, and it's all gone through. So that solve took me 45 seconds, so considerably faster than my local machine. And you can see, because it took 45 seconds rather than my predicted maximum 1 hour, the job actually only cost me 14 pence out of a maximum of £18.30. So yeah, a lot cheaper than I was predicted. I can also do things like look at the residuals. For a very short job like this, it's not so useful, but for longer running jobs while it's running, you can track the residuals and see how your job is going, if it's going to converge or not. So now in the background, Epic is uploading the results back to my Epic data store. It takes a couple of seconds, and then I should be able to view the data by following this go to data folder link. Okay, so that's done. So we go to the data folder. Okay, so you can see here it's uploaded the reconstructed time steps that are requested up to 1,000. I can then potentially download the data. I can look at the data in the browser. I can download it using an AWS tool, or also have the option of visualizing using these desktops, which is what we'll have a look at now. So desktops start a remote visualization node on the cloud in the same location as the data. So if your data sets are large and you don't fancy downloading multiple gigabytes of data, this is a very quick and easy way of doing it. So to do it, you just click on New Desktop, and you've got two options for Foam. You've got PowerView Server, so we can start PV Server up remotely and you can connect to it from your local PowerView client, or a more flexible way is using this Epic Desktop, which gives you a remote Linux desktop based on the Nice DCV visualization software. And then you can use things like Foam and PowerView on that desktop via your browser. So I'm just going to fire up a DCV node. Okay, I want to select the data I want to visualize. So you've got two options with data, online or offline. So online basically mounts whatever you select as a drive on your Linux node, and any changes on your Linux node are copied back to your Epic data store. Or you can do an offline data set, which puts a copy of data onto the visualization node but doesn't synchronize back to Epic. So the online option is good for me because I might want to save some changes, and I'm just going to visualize have access to all of my data. Okay. I'm going to connect using Nice DCV, and I've got 3 node sizes I can choose from: a standard, large, or extra large multi-GPU. So I'm just going to use a standard desktop for 1 hour, and that will cost me 99 pence. Again, I'll only get charged for the time I'm actually using. So I shall go ahead and launch that. And then on my active desktops, I've got this node here, which is now launching. So we just wait for that to launch, and then we'll be able to connect to it. Okay, so my node is now ready for connection via DCV, and you can see in this connect dialog it gives you the instructions to do that. So I'm going to click that and it will open up the connection in a new window. Okay, and then its username is Epic, and then that's the password. So I found the easiest way is just to copy that into the clipboard, and then you can just Epic and then paste that in. That logs you into DCV and then connects you to the Linux desktop. So now you just need to log into the Linux desktop. Again, you need the password, so right click and paste tends to be the easiest way. It should still be in your clipboard. If it's not in your clipboard, you've got this copy and paste between the client and the desktop here. There is also a DCV desktop app if you want it, if you want to use the browser, but the browser tends to work quite well. Okay, so I'm now logged into my Epic desktop node. You can see here I've got a link on the desktop here for data, and I can see the foam motorbike case that we uploaded earlier. is there. And if I wanted to launch PowerView, I'll just go full screen on this. If I did want to launch PowerView, I can go to Applications, System Tools, Terminal, and all the applications are presented as modules. So if I type module avail, it tells me what's available. So various tools and also foam extend, OpenFOAM, and PowerView, and visit. So if I do module load PowerView, and then just launch PowerView. A couple of seconds, okay. So then I can open, go into my data folder, just as an example. So if I just open the control dictionary, the foam reader. Okay, so then I can load and interact with my data on a desktop. So that's all there, and it's all 3D accelerated with the GPU on the remote node. Having foam is also available is also quite useful. So if I do module load OpenFOAM, then it puts various versions of foam into your path. So then I can do OF 1906 to get that particular version of foam, and then all the foam binaries and tools and libraries will be available for me, which is quite useful for post-processing your cases. Any changes I make in my data store are reflected back to Epic. So if I go into my data, into foam, motorbike, okay, so say I create a new file, okay, then I've got that test file there, and then I can log back into Epic, and that will be automatically synced back to my data store. So if I just go and have a look, so we go and refresh my case here, the motorbike case. I can see now you've got, yeah, that's that test file just created. So I can synchronize my data back and forth like that. So any screenshots or videos you make in PowerView will be available if you copy them onto your data. So that's it. That's how it's. We've made it quite simple and hopefully quick and easy to get a foam case from running locally, scaling onto a remote cluster, and then also visualizing in the cloud. So please, there's £10 free credit. Please try it out.